Hi everyone. So today we will be discussing about SHAP methodology for interpreting machine learning models. So in my previous videos, I have already discussed how PDPs and LIME works for interpreting black box models. Now third in the category is SHAP. So we'll try to understand how it works and eventually we will see its mathematics behind it. So SHAP is almost similar to LIME if you followed my last video with a few subtle changes that we'll be discussing. So first of all, first of all, you need to train out the your black box model. We will be assuming that we are training a neural network on some binary classification, right? Uh, the first step would be to pick up a random sample from the training data set. Assume this sample to be X. Now you need to generate a, an artificial data set out of this random sample. So if you remember from our last video from Lime, we did the same thing. But in that case, we first of all generated summary statistics for the entire data set. And then eventually we generated a random sample. But in case of Shape, what we are doing is that using the random sample that we have picked, we are trying to calculate, we are trying to generate an entire artificial data set. So how it is done? Basically, it follows the ideology of collision. So what we are trying to do is that assume that we have four features a, B, C, D. So how we will be generating random samples for the artificial data set is we will be turning on and turning off some of the samples. So let's understand what does this mean. So by turning on, we mean that take the same value as in X for that feature. So for example, if we have A, B, C, D as four features in the data set, and we are turning on A and D, and we are turning off B and C. So turning on means that so the random sample that we picked up in the first step, we'd be using the same value for that feature. We will be looking that for an example below. And turning off means that what we would be doing is from the training data set that we have, the remaining samples, not the one that we have picked up, we'll be picking out some random value for that particular feature. So assume that if the random sample X that we have picked has these values, A is equals to 10, B equals to 20, C equals to 30, D equals to 40. Assume that we have four features for the binary classification and we kept on A and D and off is B and C. So the new sample may look like A equals to 10, B equals to 60, C equals to 100, D equals to 40. So if you know, you can note the changes. The features that are turned on A and D has the same value as the random sample X that we have picked up, right? But for the features that we have turned off B and C, the values have are randomly picked up from the training data set. This is the change. This is how we will be generating multiple samples using the same random sample that we have picked up from the original data set by following all the permutation and combination. So sometimes we will be turning on just A, remaining are off. Sometimes all are off. Sometimes one would be on, others are off, etc. Sometimes all are on. So following all this permutation, we will be generating multiple samples. Once the artificial data set is generated, we will be assigning weights to the different samples present. So if you remember, like in Lime also we did the same thing, but using distance or the some kernel, distance kernel, some width kernel. But in case of Lime, we will be following SHAP kernel. So basically, it means that how weights are getting assigned to these random samples in SHAP is that any feature, any sample that has a low entropy in terms of on and off features would be given higher weightage as compared to the ones which have a higher entropy. So by entropy we means that if you look into the samples by entropy we mean that highly imbalanced on and offs in the entire feature. So for example, if we have in a sample four offs and one on, like considering uh, a sample with five features, the weightage for such a sample would be greater than as compared to a sample with three offs and two ons. As you can see that it has more imbalance in the two on and offs as compared to the second sample. Now in the second example, you can see that weights for three ons plus two offs is equals to weights for three offs plus two ons because the imbalance is same. So the weights would be assigned same. Similarly, if all are ons plus if the weight for all ons would be greater as compared to 4 offs plus 1 on, because as you can see that the imbalance is higher there. So depending upon the imbalance in on and offs, the weightage would be assigned to each of the random sample that we got. Similar to Lime, we will be training a white box model on the weighted artificial samples that are created in the previous step and interpret this white box model. So the interpretation of this white box model would be considered as the interpretation of the black box model that we are trying to interpret. So, just a last liner, the difference between the methodology between Lime and SHAP. So you must have noted that the artificial dataset generation method is different. So in Lime, we are using summary statistics, but in case of SHAP, we are using a single random sample, and weight assignment is also different. So in case of Lime, we were using a distance metric or some kernel weight, but in case of SHAP, we are using a specialized kernel called a SHAP kernel that gives us weightage depending upon the entropy of the on and offs in the particular sample.